All right, Math 20. So this is lesson 1 of the statistics unit. It's called Measures of Central Tendency. So this will kind of guide the rest of the unit, these definitions and everything that we have in here. And what you'll notice with each of the lessons, there's kind of a page of, here I'll do it in this document that I have here. So there's a page of the notes. Scroll down this way. So I'll go over those and the definitions. And then you'll see a lot of these pages. So this comes from a statistics guide booklet that's actually really, really good for explaining things out. And that's why this booklet is so thick, because it's got a whole bunch of the sections out of this statistics booklet. So we'll use both of these to kind of guide our understanding. The information in it is or the instructions at least, are for the TI calculators. And so I do have the information about how to do this with a Casio graphing calculator as well. So you just need to let me know if you have a Casio, because it's a little bit different, but it's still really easy to do in the calculators. So let's zoom back here. So central tendency. Get everything together here. So central tendency. The way that we're going to define this is a central or typical value for a probability distribution. And the word that we often use for this is, we often use the word average. I think in your notes I actually kind of deleted this portion. I haven't updated my smart file. So moving along, so measures of central tendency. So we're going to talk about a couple different terms that are different ways to talk about central tendency. So typical values or central values. They're all a little bit different though, so they're specific words. The word mean is the sum of all the values in a data set. So again, when we're talking about sum, we're talking about addition, the sum of all values in a data set divided by the number of values in the data set. So an example there, it says calculate the mean of, and then we are given in total 7 numbers here. So 25, 22, 23, 23, 31, 28, 29. So calculate the mean of these 7 numbers. So what we need to do first is figure out the sum of the numbers. So again, we're going to add them up to figure out the sum of the numbers. So if I punch in a calculator, 25 plus 22 plus 23 plus 23 plus 31 plus 28 plus 29, we get a sum equal to 181. The number of values, I already mentioned this, but you would count up how many different numbers there are, how many numbers are there. So 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers there. So in order to figure out the mean, we take the sum and divide it by how many data points or how many values are within the set. So 181 divided by 7 gets me 25.86 is the mean. And that should, you should look back at your data set and say, does that make sense? Yeah, that's a number that's somewhere within this. If we had gotten 40, well, 40 is bigger than any of these numbers. So that wouldn't make sense. You might have clicked something in your calculator wrong, put in 250 instead of 25. So make sure that your answer does make sense in the end. So the mean of those 7 numbers is 25.86. The next term that we're going to use is the word median. So the median is the middle value from an value from an ordered data set. Sorry. Which separates the higher half from the lower half. So the next one here, it says calculate the median of 46, 42, 53, 45, 50, 35, 50. And so what we need to do first is we need to order this. So I mean putting from lowest to highest. So if we order that, the lowest number is 35, we have 42, 45, 46, we have a 50, then we have another 50. Yes, we do need to write it twice since we have that number in there twice. And then we have a 53. And so again, we've ordered it from lowest to highest, so we want to find the number that separates the lowest half from the highest half. So if we look at 46, there are 3 numbers below 46, there are 3 numbers above 46. So our median value for that is 46. The next one's still on median. So we have a couple numbers there. So organizing it, 33, 38, 39, 45, 50, and 52. So in this case, we have 6 numbers. We have an even number. So to figure out our median, we need the halfway point between those 2 middle numbers. So we have 2 numbers below that, 2 numbers above that. So we need the middle point between those 2 numbers. So what we need to do, sorry, I've got a tickle in my throat right now. There we go. So we need to take the mean of these two to find the median. Where we're looking for the halfway point in between them. So 39 plus 45 divided by 2 gets us 42. So our median for this set of numbers is actually 42. So that's not a number within the set, but it's our halfway point between 39 and 45. So our median for that set of numbers is 42. The mode is one that we definitely see way less. It's not one that we usually use. Mean is going to be our big one that we're going to use, the first kind of definition that we had there. Median, sometimes. Mode, not really going to be used, but it is a measure of central tendency. So the mode is the most frequent value. In a data set. So sometimes you can tell just by looking at a data set. If you have too many numbers, usually you actually do need to organize it in order to determine what the mode is. So I'm just going to order it. So put it in order from highest or lowest to highest again. So 23, 23, oops, 25. Oh. So we see that the only one that repeats itself, again, that's saying the most frequently, is 23. So the mode is equal to 23. Again, mode, not really going to be a big part of our measures of central tendency, but still a good thing to understand. So again, it's the most frequently seen. If all numbers are only seen once. There actually is no mode for it. But if you have anything that appears more than once, that will be your mode. So the following data represents the top 10 class marks in a math class. Calculate the mean, median, and mode for the data set. So this is a data set. These are the top 10 class marks. So mean, median, and mode. So we know that for median and for mode, we're going to need to order it. So put it in order from lowest to highest. So 77, 79, 80, 82, 85 twice. Sorry, it's getting messy. 89, 90, 91, 92. So the mean, again, we need to add it all up. So add and then divide it all. So 77 plus 79 plus 82, 80, sorry, 80, 82, 85, 85, 89, 90, 91, 92. If you add that all together, you get 850, and we're dividing by the 10 scores that there are. So the mean of that is 85. That should make sense, right? Our data goes from 77 to 92, so your mean should be somewhere within that. Median, again, is the middle point. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is 85. Again, 85 plus 85 divided by 2 is just going to be 85. So our median is 85. And our mode is our most frequently seen data point within it. So that would be the only one that repeats, which is 85 as well. So the last portion, or the last definition that we need for measures of central tendency, oh, it disappeared off my page, is the range. So the range is the difference between the maximum and minimum value in a data set. So for the last example, it says calculate the range for example 5. So that was those 10 math scores. So the maximum, if you look back once I had ordered it, the maximum was 92. The minimum was 77. So the highest mark was 92. The lowest mark was 77. So the range of those data points is 15. I think I took this out of your notes too. So I left this one in though. So it says example, the lifespan of two different types of car batteries are shown below. So brand X and brand Y. So this is getting a little bit bigger where it's not as easy to see what is the mean, what is the median. So in each of these, there are 30 data points. So they took the lifespan of 30 car batteries from brand X and 30 batteries from brand Y. So you can punch these all in your calculator one by one, add them all up, or try to order it all. It gets a little hairy though, right? If you put in 50 instead of 5.0, you end up with a median that's way off, or a mean that's way off. So we're going to actually use our calculator, some of the special functions within our calculators for this a lot more. So I'm not going to go through doing this one. We'll do it in the statistics booklet. So if we actually did the calculation that we're going to learn how to do, brand X, when I find the mean, it's actually 5.74. Brand Y, the mean is actually 5.72. So this has a longer average lifespan. but not by much, right? That's pretty close, 5.74 and 5.72. That's basically, a week or two difference in terms of car batteries. But you can look at how spread out the data is as well. So something like the range would be important here. So if we look at brand X, we see some of the batteries, oh, there's even greater numbers. Some of the batteries will last greater than 7 years, but we also see that some of the batteries will last only 3 years, whereas with brand Y, all of them are pretty consistent, right? There's nothing that's going to last you 7 years, but there's also nothing that's going to conk out on you after only 3 years. So we'll talk about that when we start to look at dispersion of data and how spread out it actually is. So did I put this in? No, I didn't. So just flip over to the next page in your booklet. So it should look like this. And so again, these pages from the other statistics booklet are super helpful. You just got to kind of read through them and try what they're looking at. So we'll go through this set together. So it says in this unit, you'll be working with statistics. Statistics is the collection, organization, presentation, interpretation, and analysis of data. Statistics is one of the most prevalent branches of mathematics in everyday use. So that's why I think this unit is so important. There's so many things that rely on statistics, and that we know that the media, such as newspapers, radio, television, and the internet, there's statistics all over the place. So thinking about where data comes from and how it's representative is super important, because sometimes the misuse of statistics can present misleading information depending on how it's presented. So the first topic is, again, what we've looked at already. So measures of central tendency as well as histograms. We didn't talk about that in our notes. So we're going to use this same example for the next couple of days. So it says a group of friends were arguing about which fast food restaurant produced the best French fries. In an attempt to resolve the dispute, they asked their friends to rank the fries of nearby restaurants out of 10. The results for one restaurant are listed below. So fries at restaurant A. So whatever. Let me, no, it will not. It'll just let me highlight. No, it will not. I can't really do much in Adobe with my smart. Uh-oh, I've made a terrible mistake. So fries at restaurant A. So whatever, we'll call restaurant A McDonald's. And so they said, what do you think about McDonald's fries out of 10? So what it shows here is one person said, I hate McDonald's fries. I'll give them a 2 out of 10. They're wrong, but that can be their opinion. So one person gave them a ranking of 3. 2 people gave the McDonald's fries a ranking of 4. 4 people said, I'll give it a 5. They're good, they're okay. 5 people gave it a ranking of 6. 2 people gave it a ranking of 7. 1 person gave it a ranking of 8, and 1 person gave it a ranking of 9. Nobody gave a 1 or a 10. I guess nobody loves it or hates it that much. So the first question it says is, how many people took part in this survey? So how many friends did they ask? So what you would need to do is add up the number of people that gave each of these rankings. So 1, 2, 3, 4, 8, 13, 14, 15, 16, 17. 17 people took part in the survey. For question B, it says, how could you find the average rating of this group of friends for this restaurant? So they're using the word average rating. And so what you need to think about in terms of our measures of central tendency is, what is that asking? And it's likely asking for the mean. So the way that you would find the mean is you would add up the rankings and divide by 17. So we would add 2 plus 3 plus 4 plus 4. Again, 2 people gave a ranking of 4, so you'd need to add it twice. Plus 5 plus 5 plus 5 plus 5, and so on. And then you would divide it by the number of people that were surveyed. So 17 people surveyed in total. Question C is saying, what is the most frequent rating? So 5 people gave it a ranking of 6. So 6 was the most frequent rating. Question D, don't worry about. You don't. That's kind of talking about the range a little bit, but not necessarily. So gathering information, it says the mean, median, and mode are called measures of central tendency. They are all considered averages and describe the center of data. So again, terms that we've already seen, but let's just review it real good. So by adding the number of people who voted, we see that this is a group of 16 friends. Finding the average ranking is a bit more difficult. Most people find the mean by adding all the numbers up and then dividing by how many numbers there are. In this case, we would add 1, 2, 1, 3, 2 4s, and so on. So if we would string out the numbers from the chart, this is giving us all of the ratings. So there's 17 numbers here between 2 and 9 for a total of 17 numbers. When we add them up and divide by 17, we get an average ranking. This average is another word for mean of 5.5. So the mathematical name for this statistic is the mean, although most people just call it average. So finding the mean with the graphing calculator. So this is helping out a question like this one, where we have a ton of data. And it's just a little bit tedious to try to put it all in the calculator. Even with this question that had 17 pieces of information, it's kind of nice to actually do it with the calculator instead. So there are two different methods. And again, these are the pieces of information for the TI calculator. So two methods. So method one is working with the raw data. I'm going to see if I'm not. I made a mistake. I don't have it in here. So these get you the same thing in the end. It's not a big deal. So I'd say for now, let's start with method one. So working with the raw data. And what the raw data is this piece of information. So from this 2 to the 9, that's our raw data right now. We'll talk about method 2 in a little bit. That's using the table from the previous page. So the way that you get to this is you press the stat button. So it's kind of near the top, over a little bit to the right. So it's a stat at the top there, and under the edit menu, it should be the first menu, it says go to number 1, which says edit, and press enter. So there shouldn't be anything in your calculator right now, but if there is, you can clear it out. I can't remember if you press clear or delete in each of them and then press enter, but you should be able to clear it out. So if you have anything in there, maybe pause it and delete everything out. You can also go up to the top. So if you scroll up beyond number 1 and go to L1, if you go up there and press clear and press enter, it will actually clear out the entire column. So in L1, once you've got everything cleared out, you want to enter your data. So you want to press 2 and then press enter so that it goes on to the next line. And then press 3, enter, 4, enter, 4, enter. So you keep doing that until you have 17 numbers entered, each on a separate line. So you might need to recount to make sure you didn't miss one of those 5 6s or something like that. But you should have 17 numbers entered. So now you press the stat button again and you scroll over when you're on that main menu. So you scroll over to the one that says CALC, so calculate, and choose number 1, which says 1 var stats. So that's single variable stats or 1 variable stats, and press enter. And so this appears on your screen. So the 1 var stats appears on your screen. The calculator is ready to find statistics on a list of single variable data. And again, that's what we're looking at. It might not go straight to your 1 var stats. The TI 83s and 84s and 84 pluses do a little bit of a different thing. And I don't have an 84 plus here. So if that's what you have, once you press enter right here, it might take you to a little bit of a different screen, which I think you just need to scroll down to the word calculate and press enter, if I'm not mistaken. If you have trouble, let me know and we can work over it together. But again, I think most of this comes from the TI 83 or 83 plus, I don't remember. So you might just need to scroll down one more part. So 1 var stats appears on your screen. Oh, you might need to do this step depending on the calculator you have. But what you should eventually get to, if you can't get to a screen that looks like this from this data information, you need to pause the video and we need to chat about it because this is super important that you get to this. So you should see something that says one of our stats, and then the top one should be X with a little line over top, and it says 5.5294, and then something that looks like a really weird E with an X, E with an X squared, kind of an S with an X, and so on. And then you see there's a little arrow down that says N equals 17. So the very first one, this X with the line over the top, so it has a little line on top of it, is actually our mean. So as it says here, the calculator uses the symbol, oops, X with that little bar on top to indicate the mean. So sometimes you'll see, or you'll hear me call it X bar, but that's just the symbol to indicate the mean. We'll see it another way a little bit later as well as a representation of the mean, but the way your calculator will say it is X with that little bar on top. So that gives us the mean of our data, so 5.5294. So that's the same number we would get if we punched all of those into the calculator and then divided by 17. That's actually what it's doing. Oops. So this is working from raw data. Pretty straightforward as far as you can say. You need to remember these calculator strokes, or you need to practice doing them. They should kind of become second nature with it a little bit. The next one, is working with a frequency distribution. So this is method 2. And before I get chatting about it, you see that we get the same thing. Your screen ends up being the same way. So you can do either of these methods. It just depends on how your data is actually given to you from the beginning, which one is going to work best. So right now we have a frequency table. So it actually would be easier in this one to do method 2 from the beginning, but since we have it ordered here, method 1 is pretty easy to do as well. So method 2, the way that we would do it, as it says here, it's faster but a bit trickier. If you wanted to do it from a frequency table, you press stat under the edit, go to number 1. Again, you're going to need to clear out the stuff that you had in there previously. So what we're going to do here is instead of entering the individual pieces of data, we're going to enter the equivalent of this table into the calculator. So in L1, again, that's list 1, enter the rankings from 2 to 9. So you're going to put in 2, 3, 4, 5, 6, 7, 8, 9, and then you're going to scroll over to L2. And next to the 2, you're going to put in a 1. That's saying a ranking of 2 was given by one person. A ranking of 3 was given by one person. A ranking of 4 was given by 2 people. So you're going to have a 2-column chart that should match up with this table pretty well. So entering them all into L1 and L2. You might need to pause it if I'm going too fast. Entering them into L1 and L2. So again, same thing, you're going to press stat, go over to calculate, and you're still looking at single variable statistics and press enter. So again, this is a little bit different for the TI-84s versus TI-83s, but this, it should say on your screen if you have a TI-83, 1 var stats, and then what you do is you put in, then what you need to do is you need to put in L1, so that's one of those alpha buttons, I believe, and then you put in a comma, and then L2. So that's saying pull my single variable stats from list 1 and list 2. So you'll put in that L1, comma, L2, and then you press enter. TI-84s, once you press this enter, so once you're at stat, calculate it, number 1, I think TI-84s, it actually gives you a spot where you can put this in. So you scroll down, it says something like frequency list. Again, if you're struggling with this, I don't have an 84 with me right now, or an 84 plus. So we'll need to have a video chat and figure it out. I think it'll say, somewhere it'll say L1, and then I think it says freq list or something like that, like FREQ list, and then you're going to put L2 in that. So play around with it, try putting those in and then press calculate at the bottom until you get to this one var stats part. And again, it should look the same as your method one. So that same number for the mean, so x with the bar over top, giving us our mean of our data points being 5.52. So the other thing that you can see, I didn't mention this before, is n equals 17. That gives us the number of individual pieces of data that were in there. So we counted that up before, but if you put it in from a frequency table, like you're doing this method too, it can tell you your number of data points that you have. So the mode is a piece of data that occurs the most often. We've already talked about that. I'm not going to go over all of it, but you can keep reading. And the range is the difference between the highest and lowest pieces of data. So it's a measure of dispersion, and it talks about how much the data is spread out. So you can read through that. I'm trying not to make this like a 3-hour lesson. So the next one, it says displaying our data on a histogram. So a histogram is a type of graph, the type of bar graph. And what you see is there's no spaces in between the bars. So the item being studied is placed in equal intervals along the bottom of the graph, and the frequency of each item is up the side. So here we have ranking along the bottom, so we could have ranking of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the frequency of each of those rankings up the side. So we know that one person gave a rating of 2, and one person gave a rating of 3, and 2 people gave a ranking of 4, and 4 people gave a ranking of 5. The ranking of 6, there was 5 people. You can finish off this bar graph, right? 7 people gave it a 2. So you draw the little bar here. I can't do it on mine. And 8 and 9 both gave a ranking of 1. So you'll have the bars there for 8 and 9. So finish the histogram on your own there. And that gives us kind of a visual of what it actually looks like. It says, of course, there's also a fast way to do this on most graphing calculators. So you can look through, I don't usually do histograms on the calculator, but you easily can. So you might want to put a star next to this. If you haven't deleted the stuff from the last question out of your statistics, it's pretty easy to do. So maybe pause the video and kind of follow along with these instructions and figure out how you can graph it. One big thing at the end. Oh, sorry. You can only do this for your raw data. You won't be able to do it from the frequency table. So you can only do this from the method one part. So you might need to pause and put in the method one way where you had 2, 3, 4, 4, 5, 5, 5, whatever. So you might need to put it all into list one for that. But you can plot it out. The one thing is you need to turn the plot off after you've done. So moving this cursor to on, you'll need to move it off later. Sometimes it can just mess up things in your calculator later. Oh, sorry, I said this was only for raw data. If you want to do it with the frequency table, that is how we do here. You'll need to adjust your window settings though. You probably have your window still the same from quadratics or something like that. So you'll need to adjust your window settings in order to actually see your graph. So this gives us some window settings. So our X values along here were the rankings between 0 and 10, and our Y values, so that's our frequencies. Again, the highest number was a 5, so you probably want to go between 0 and 6. So you should get a graph like that. So you can always make graphs by hand, or you can do them in the calculator as well. Okay, this part I think I have in my Smart Notebook file. So it says the height of students, sorry, I have a meeting at 2 that I don't want to miss. The height of students in a homeroom were recorded in centimeters as So we took Tammy and Alana's homeroom or something like that and looked at how tall everybody was in centimeters. So 168, 140, 150, 185, yada, yada, yada. Um, and it's asking us find the mean, median, and mode, as well as the range of the data. So I am going to do this. I'm going to use the method one because I have raw data. I don't have a frequency table. I just have raw data. And it would be pretty hard to have a frequency table for this because again, we don't have ranges, like we don't have people that are between 140 and 149 and 150 and 159 and so on. So we're going to need to use method one for that. So what you need to do again is go into your calculator, clear out anything that's in there, and then put all of those pieces of information in. They don't need to be ordered in your calculator. Your calculator is smart enough to figure out what order it goes in, so you can just put them in as it goes. So you're going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. And again, you don't need to order them. Your calculator will sort all of that out. So once you've put it all into L1, you press Stat, scroll over to Calculate, your 1var stats. And again, you're going to pull your 1var stats from list 1. So you should get, hopefully you've paused the video and done it because practicing this is super important and you know this is right. So if you don't get the same thing, you have made a boo-boo. So single var stats, the requested information. So mean, again, that's that X with the little bar on top or the little line on top. So when you do that, it's not showing on this screen. Sorry, they've actually scrolled down. You see how there's little arrows up and down the sides? They've actually scrolled down. So the mean actually would have been at the very top. The mean is 167.5. So again, that's that X bar part. The median, to get to the median, you actually have to scroll down. So that's why this screen is showing this. So we scroll down to the MED, and that gets us 168. So our median value, if we were to order these from lowest to highest, our middle value would be one of these 168s. Our mode, can't get that out of the calculator. There's no, if you scroll up and down, there's nothing that says mode or anything like that. So you just need to look at your data points and figure out, do any of them show up more than once? Which one shows up the most? That would actually be the 168 as well. And our last piece of information of central tendency would be the range. So the maximum number, subtract the minimum number is our range. Our maximum number was 194. You can actually find that, oh, I don't have my calculator in front of me. I think if you keep scrolling down, oh yeah, here, sorry, minimum X, so our minimum is 140. I think if you keep scrolling down, there should be something that says max X. So again, if you don't want to look through here and try to figure out the highest number, your calculator will tell you. So our range will be 54. Oh, I should have just kept reading. Min X and max X can be found in the statistical analysis. So the only one that you really can't find in your calculator is the mode. Everything else you can find at least enough information to answer it. Oops. So histograms, I'll leave that for you to create a histogram for it. It kind of gives you some information, but just if you need to plot out a graph, it is very helpful to be able to do it by calculator, or you can do it by hand. So, oh, I guess I don't have much in here. So definitely always do the questions in this for homework because they kind of continue usually into the next day. So the practice questions are these three. I guess not even really three, it's A and 2 because this is not actually a question, it's just a chart. But you might also want to peek into the textbook. I don't have the textbook in front of me right now, but find the statistics unit and just do a couple of the practice problems from the statistics unit. So our next topic will be standard deviation. So make sure you've done all of the questions for sure from in here, but also peek at some of the textbook ones. Just practice for putting it into your calculator. It gets more complex. So if doing these seem really difficult, it's only going to get worse. So I would recommend using your textbook to practice a couple of these types of questions, either working with raw data or working with a frequency table or a frequency distribution. So that's it. That's all. We'll talk to you later.